Good morning, folks. So I know we had that issue last time where I got my computer had some problems. I think there's a couple of things that sort of could be involved in that. One of them might actually be the camera itself. So if we do have some sort of issue like that today, then I'll probably have the camera basically disconnected at some point if we have any issues. Today is file I/O, and it's sort of an extension, at least somewhat, of the stuff we did last time. So we talked about exceptions, and the sort of try-catch block was sort of the main thing last time. When you do file I/O in Java, using those try-catch blocks are necessary in most cases, and they can be helpful as well. Make it so you can write a little bit less code. So I/O stands for input-output. We've used scanner to read stuff in from the keyboard. So we have a scanner, we send in system.in. So we've seen system.in before, it just goes into the constructor for the scanner object. So that's how we get stuff from the keyboard. And we have system.out for all of the printing to the screen. So we type system.out.printf, and that's how we output to the screen. So those are predefined input-output objects, and Java includes them sort of automatically in every program. So we can use system.in plus a scanner, and we can use system.out plus a function like printf to read from the keyboard, print to the console. So the point is that we can do this with files as well. So that's what today is. We can also use files for input, and we can use files for output. So not just the keyboard and the console. The reason why you might want to use a file is that as soon as your program is done, all of the data associated with that program is gone. You don't have access to it anymore. So the simplest sort of example of this is something like a save state for a game. Now you're playing a video game, you make some progress in the video game, you want to save that data out. Files might store a little bit of data, they might store a lot of data. In the scientific sort of nuclear physics stuff I did, we had files that were gigabytes and gigabytes in size, storing various data that we needed for doing the runs of our program. A lot of like save game files or just sort of basic text files might only be a few bytes in size if you only need to store a small amount of data. The point is, for files, it's how you save the program state, or at least some of the program state, after the program ends. So files are, of course, very important then in pretty much all programs. So in Java, files are represented with a file object. So if I grab my spotlight here, a file object. So you create a file object in Java, say file F, give it a name. F is a file is the type, F is the name. And then you say new file, and the file name is what you put as a string here. Whatever the name of the file that you're trying to read, or the name of the file that you want to create. New file objects, like this, are needed for every file that you want to interact with. There's lots of methods that you can use with file objects, but we're actually not going to directly use this file object. We're going to combine it with two other objects, one for reading, one for writing. One of them will be very familiar, and the other one will have some familiar functions. So the nice thing about dealing with files in the way that we're going to do it is that you've actually already used almost everything that we're going to look at here today. It's just using it with a file instead of the keyboard or the console. So there's some niceties there. So reading from a file is done with the scanner. We've been using the scanner. We've used the scanner almost the entire semester. But this time, when I create a scanner, I'm not going to use system.in. I'm going to use a file object. So I'm creating a scanner for this file, this test.txt file. Typically, you will see me do this in one single line. So I create a scanner. Here it's called fin for file in, and it's a new scanner. And then instead of system.in, it's new file and the name of the file that I want to read. That's it. And then the scanner works exactly the same way, except it's not from the keyboard. It's literally reading from the file itself. So when you create a scanner, Java opens that file for reading. This is where the exceptions come in, the stuff from last time. If the file doesn't exist, let's say you misspell the name or the file just for whatever reason is not there, then Java will throw a file not found exception. So you must use a try catch to handle that exception. Or if you're doing a method, you can use the throw. You can use the throws in the method. The point is, handle it somewhere in your program, because this has to be taken care of. If the file is not there, Java essentially has to stop. Whatever you're doing has to sort of stop happening because you're trying to read from a file that doesn't exist. So this is why we use a try catch when we mess around with a scanner that's connected to a file rather than the system.in, rather than the keyboard. So that's where these two things sort of intersect. If you're trying to read a file or write to a file, which we'll get to a little bit later, you have to have a try catch around some of that region. When you no longer need a file, it is important that the file is closed. If your program crashes or terminates, let's say you have a file open and the power goes out. So say you're on a desktop, so not a laptop, for instance, but let's say the power goes out and you have a file open. That might corrupt the data in the file. There's various reasons for this. The file is not written to in real time. Typically, there's buffers that data or whatever you're trying to save to the file gets written to buffers first, and then sometime later it actually gets written to the file itself. When you close the file, you basically force that process to complete. So your data may not actually be written, and if the data is not written and the program crashes or the power goes out or something happens to terminate your program, that data may not ever get written to the actual file itself. So that's why the file can become corrupted. If you've played sort of video games on consoles or on PCs, where when you start up the game, it says don't turn off the power when you see this icon, and it'll show some game icon blinking or something, that's because a file is open. So the game is doing some sort of autosave, and it opens a file, and it's writing the data to the file, or it sends the stuff out to the buffer, and then when that icon goes away, it closes the file so you can guarantee that the data has been written. If the power goes out, or you turn off the console or the computer, or it crashes when a file is open, it may corrupt it. It may not. It depends. But you certainly wouldn't want to risk it on, say, a save game or something where you've put in 100 hours into the game, for example. So that's why those little icons are there. It's because of this exact process. So there's several ways to handle closing files. Based on the code that you guys have written, some of you have probably seen it before. You can easily close a scanner. So some of you do that. Some of you say input.close at the end of your code. That is a way to close a scanner, which, if that scanner is connected to a file, will close the file. But we are going to use a mechanism that sort of newer versions of Java, basically 8+, implemented. And it's all based on try blocks. It's called try with resource. So it's a little modification to our try catch block, but it makes it so we don't have to remember to close our files ourselves. So as a programmer, it makes my life easier with just a little bit of syntax modification to the try catch block. So that's the idea of reading a file, opening it, and closing it. So we're going to look at some examples of this, and I'm going to show you how to interact with those files. So we'll start very simply, and we have a couple different examples I'm going to talk about today. We're going to sort of build on them as well, so we'll come back to some of these specific codes. So this one is very simple. It tries to open a file called test.txt, and currently it doesn't do anything with it. It doesn't try to read anything or something, but we will add stuff in here a little bit later. So your basic sort of foundation for reading a file, and I just have a quick an empty class here. I have a few empty classes because we have a few different types of examples, but none of these have any code sort of already in them. They're all just empty classes. So the first thing I want to do, if I just want to read a file, I start with the scanner like I always do. Typically, I denote in some way that there is a file associated with this scanner. So something like fin is sort of useful. You can come up with your own conventions if you want to, but in this case, I'm saying this is a file in scanner. And I do the normal stuff for scanner after that. I say scanner, or say new equals new scanner, and then I do that new file thing. So I say new file, and I put in the name of the file as a string that I want to read in. So I want to read test.txt. Now we have a couple of errors. Scanner, I need to make sure to include that, of course, and file also needs to be included. This comes not from Java util, but from Java IO. So java.io for input output file. Now, if I just open the file like this, look what it says. You might have to squint a little bit. It says unhandled exception type file not found exception. So if I try to open a file like this, Java immediately tells me you need to try catch around this. So that is an error that you will get. That's why we talked about try catch and sort of exception stuff first, because of this, because we do get an error if we try to open a file. So I need a try catch. So I'm going to put in a try, but I'm going to do the try with resource. So remember our previous try catch. Let me just outline a try catch real quick. So the try catch we talked about last time was this. We had try, we had brackets for what we wanted to try to do, and then we had a catch with an exception in the parentheses, and then brackets if we hit that exception. So this is our standard try catch. So the try with resource has one change. It also has parentheses after the try. So I can take my creation of the scanner and I can put it in the try parentheses. So what's going to happen here is it's still going to run the try stuff I want to run in here. So this is open the file and read. So we're still going to put code in here. We'll do that in just a couple minutes. But this opens the scanner and the file and will potentially cause us to have an exception if the file's not there. Then when the try is done, so after we finish the try catch block, the file automatically closes. Because of try with resource. So because I put the scanner in here, it will automatically close the scanner when I'm done with the try catch block. So I don't have to remember elsewhere. I don't have to say fin.close. I don't have to do that, which is sort of normally what you do to close the file. So I don't have to remember that, which is actually quite nice. The exception that you might get is what I mentioned before, file not found exception. I'll call it EX. This one also needs to be imported. So this file not found exception comes from Java IO as well. So file and file not found exception both come from java.io. And then I can put whatever I want to in here. So I could say system out printf. I could say the file was not found. And I'm going to show something else in just a moment related to this variable of type file not found exception. I'm going to show you something else we can do with this. And then we'll do a system.exit. So if I try to run this now, I don't have a file called test.txt anywhere in my project. So if I run it now, it tells me the file was not found because I don't have a file to open. There is no test.txt. I'll show you how we can create that file in just a second. If you want more information, so this just says the file was not found. Let's get a little bit more information in here. So I'm going to print out something else as a string. So before my new line, I'm going to put a string in. I can get information about what file was not found by this variable ex that's part of my catch. So I can say ex dot, and there's a few in here. We can try get message. What's the message that this exception would give us? So if I run it now, it says right here, this was the message. I typed in the rest of this. I typed in the file was not found. The message that this contains is test.txt. The system cannot find the file specified. So I can get a little more information out of this variable, which can be quite useful, because I don't know if I just print the file was not found, I don't know what file that was. So printing something about what file it was based on the message from the exception can be helpful in a lot of different situations. So this is what you should strive for your basic opening a file to read from. Use try with resource. Put your catch in for file not found exception. You could put other exceptions in as well in additional catch blocks, but you have to have this one. And then print something out and system.exit. So this should be what you go for sort of your default outline for reading some text in from a file. So is there any questions on this try catch block and sort of opening a file, or at least attempting to open a file? So that basically sort of goes through the code that was here. There's a couple of pop-ups that I have in here as well. All right, so to add a file to read in, I need that test.txt file. So to add a file to my Eclipse project, I just right-click on the project, so in the Package Explorer on the left, and I go to New. And instead of doing like a new class, like we've done before, I just select File, and I give it a name. So back in Eclipse, my project is right here. It's this in class one. So I'm just going to right click on that sort of top level of the project, and I'm going to say new, and then further down the list is file. So right click on the project, new, file. There's a bunch of stuff here, but I don't have to mess with anything. I can just type in here. I can type test.txt. So I have a name that I've given it, and there we go. So notice where it is. So over here on the left, it's not with the rest of my Java files. It's just in the base project directory. That's where Eclipse looks. If I just type in the name of a file, Eclipse looks in the base project directory for that particular file. So there's my test.txt. Currently it's empty. Let's put a few things in there. So I'm going to say hello and hi and hey, just a couple of greetings. So I just added a couple lines to it. We'll read them in here in just a second. So if I go back to that code, I shouldn't get the exception now because we can read it. We're not doing anything with the file, but we can at least see that it exists. So I shouldn't get the file not found exception. And sure enough, I run the program, and of course, nothing happens, but because I'm not doing anything in the try, but that means that the file was found. It's always worth testing this first. Whatever directory structure you have, whatever file you're trying to read, make sure that you're not hitting the file not found exception. Make sure that you can actually see that the file exists. So my test.txt over here is being picked up by my program. So now that we know that, I can actually start reading in the values here. Reading in my hello and hi and hey and all of that. So here. All right. So the file shows up under the project heading, and then you can access it and do whatever you want to. If you put the file somewhere else, you have to specify where the file lives relative to the project directory. You can do an absolute directory, but depending on, let's say you move the project somewhere else, or you package everything up and you give it to somebody else, they may not put it in exactly the same place. So typically you do stuff relative to the project directory. So we'll talk about that in just a second. So by default, the file that you create and Eclipse is going to look in that project directory itself. So if you want to open a file somewhere else, anywhere else on your system, but specifically usually inside of the project directory, then you have to use this sort of syntax. So a dot dot slash means to go up a directory. So it goes back towards whatever letter drive you have. So let's say, for example, let's say I'm in C, program files, Eclipse. So if I'm in the Eclipse directory, if I go up one, I will be in program files. So by doing a dot dot slash, I'm currently in program files rather than Eclipse, if Eclipse is where I started. Going up another directory, so if I have another dot dot slash, then that just takes me up again. So in your sort of file explorer that you would have on on either Mac or Windows or Linux, you can typically go up directories. You can click a button and it takes you up a directory from wherever you are. That's the same thing as a dot dot slash. So if you want to go down into directories, then you just use the directory name. So in this case, it's going to go up and then into desktop, and then on the desktop is the test.txt. You probably won't have to worry about this too much for CS1 or CS2, but in the future, if you have files, say, organized in some way, maybe I have a folder in my project called sprites where I store a bunch of graphics, and you want to open one of those sprite graphics, or maybe you have a folder called save game, and you want to open a save from that folder, you will have to think about the relative location of that file compared to the base project directory. So that's what this that's what this string has to contain. It's not just the file name; it's the path to the file as well. So on Windows, of course, you're going to go, as you go up, you're going to go towards C. In Linux or Mac, you're going to go up towards the root directory slash. So you probably won't have to worry about this too much, but I know that in CS2 for Final Project, folks do organize their stuff a little bit better. I've had folks do like card games and stuff, and so they want to have all the graphics for the cards in a graphics folder rather than just everything cluttering up their main source directory or their project directory. So they will create extra folders, and then you have to navigate them and that sort of thing. So for now, this probably won't be a big deal, but in the future, you may have to mess around with the relative path. All right, so now that we've opened a file, we know that we can open a file, then we can just do the same thing we do with a regular scanner. A scanner is an object. It comes from a class that has next int and next double and next line and next. All of these we've used in homeworks and in examples and labs. It's the same way that you normally would use a scanner. You even have to check for an input mismatch exception when you try to read a next int or a next double. Maybe a user put in a bunch of numbers but accidentally put in a letter at the end or something. If you try to read next int, it'll crash at that point. So input mismatch exception, you might have to catch that as well. And then again, remember, the try block will automatically close the file. So you don't have to worry about specifically closing the file yourself. So we're going to add a little bit to that code that I just wrote. And we're going to read in a couple of those lines. So back to the code here, let's take a look at test.txt. Notice I have 3 lines. So we're going to grab each one of those lines and print them out. So inside of my try, I'm going to create a string, and I'm just call string line 1. And I'll say this is fin, that's my scanner, dot, we'll use next line. So it's going to read the next line from the file. Well, where am I at in the file? When I first open it, I'm at the beginning. So this is going to read the next line. So I'll have hello. So line 1 should be hello. So let's print that out. So printf, this is a string. So I'm going to do a %s and a %n. And I'm going to put in line 1. So when we print this out, we should see hello in the console. There we go. So we just read it from the file, got that line, and then printed that one line out. So we can do the same thing for all these others as well. So we can say string line 2, fin dot next line. I'm only going to do line 2. I'm not going to bother with the third line, because hopefully you can sort of see how this works. We can print as many of these lines out as we want. And actually, I'll probably read it, and then I'll show you what error you get if you try to read past the end of the file. So here is our, we should have hello and hi. So that's our second line from our file. And let's go ahead and read in the third line. I'm not going to bother printing it out. But I'm going to try to read a fourth line as well. So let's be string. So if I try to read a fourth line, we know there's not 4 lines in this file. But of course, it's not going to stop me from doing it. It doesn't check the file first to make sure I'm coding correctly. So if I run this, I get hello because I read it in and printed it. I get hi because I read in and printed it. I read line 3. So stored in line 3 is going to be the hey, that third greeting. But as soon as I try to read a line 4, then it says no such element exception, no line found. I reached the end of the file. There is no other line here. That's it. There's only 3. So this is a very common situation. You try to read a file and you go past the end. Then you get an error like this. And it specifically tells me where, of course. I can come down here to the bottom of the red text here and I can click and it highlights this line for me. So we need to figure out a way to stop when we hit the end of the file. And so the scanner does have some nice ways to deal with this as well. So that's something that we'll talk about here shortly. So that's our basic reading in a file. And you can imagine writing out a bunch of data. So maybe you're doing something in a math class, you're computing a bunch of, you're computing points to plot on a graph or something. Maybe you want to read those points in, maybe you want to write those points out. This type of file IO is going to be able to do that for you. So of course, we're at the reading at the moment, but we'll get to the writing a little bit later on. All right, so let's do the same thing, but let's do this for integers. So I'm going to create an integers.txt file, and I'm going to manually put 5 integers in there. And then we're going to write a quick program that reads those 5 integers and prints each one of them out. So we're going to do this in a loop. I'm not going to create the A, B, C, D, and E and then print them out. We're going to do it via a loop. So I have a separate sort of blank one because we're going to come back to this one a little bit later. So I have a separate blank int class here. So just so we can sort of start from scratch rather than either adding on or deleting what we have already written. Okay, so I know that I'm going to read in from a file. So let's start with that outline of the try. So I'm going to say try. This is my try with resource. So I'm going to put the parentheses there. This, and then I'll have my catch. I'll throw that in there as well. In my catch, I already know exactly what's going to be in there. This is going to be a file not found exception. And I'll just call it EX for exception. And then in my try, this is where my scanner is going to be. Scanner fin for file in equals new scanner. And this is my new file. This will be integers, should be a string, integers.txt. Now I don't have that file yet. That file doesn't exist yet. But we do, so we will create it. Let's make sure we get rid of all the errors. So I'll hover over scanner, make sure that's imported, hover over file, make sure that's imported, and also file not found exception. So we get all 3 of those in. All right, so now I'm basically ready to go. So for our file not found exception, let's print something out real quick. So say file not found. We could do the give them more information, but since this is such a simple program, I won't bother putting it in. And we'll do a system.exit as well. So just our standard sort of print out information related to the exception and then quit the program. All right, let's create the actual file, this integers.txt. So back up in my class, in my project file. So the actual name itself, I'm going to say new file, and I'm going to name this one integers.txt. So have it here. And you could type these integers in exactly the same way you would type them in the console. Because it's just a scanner, it's just we're reading it from a file instead of the keyboard. So I can say something like 1, 2, 3, 4, 5, like this. I can do exactly this thing. Because next int, when I use that, will read in to the white space. So it'll read to the space and then stop. And then the next will read the 2 and then it'll stop. So this will work exactly the same way that you could type it in from the keyboard. So fill it with a few numbers and then we'll read them in. But I don't want to create int A and then int B. I don't want to do that. So let's just use a loop. So I'm going to say for int I equals 0. I less than what? How many values do we have? 5. We're reading in 5, and I'm just going to hard code it. Later on, we'll come back and change that. I have I plus plus. So basic for loop. And now I'm going to create an int that I'm just going to call value. And this is going to be fn dot next int. And then within the same for loop, right after we read it in, I'm going to print it out as well. So I'm going to print out a %d and a %n, and I'm going to print out value. So I get my 1, 2, 3, 4, 5. So you can throw whatever you want to inside of that try, inside of that try itself. You can throw loops, method calls, whatever you need. So again, using try with resource to open the file, and then looping through, doing this 5 times, reading the value and printing out whatever that value was. And my values, just 1, 2, 3, 4, 5. And of course, if I change one of these, then of course it's going to be reflected here. If I don't put an int, let's say I put 10.0. That's that last one. Then we're going to have a problem. Input mismatch exception. That tells me that it's here on line 10. It's when I'm trying to read it in. I say, this is an int. I'm reading in ints. And that last one, not an int. So you can still have other exceptions that happen during the read, not just a file not found. So that is something to keep in mind when you're trying to read stuff in. So in the future, when you're reading a file and it's from a save game or it's a data file that you're reading, I know that the math class, the whatever integrated calculus or whatever, they typically have sort of programming code-based stuff for some of the assignments or the sort of doing stuff with derivatives and integrals. If you have to write data to file, make sure that you're writing it out in the appropriate format so that when you read it in, you're not having an input mismatch exception if you are expecting double or you're expecting ints and they're only doubles, for instance. So that's the sort of a possible solution for this. So is there any questions on this, reading these integers in and printing them out? All right, and then of course the next slide has one of the possible solutions to that, which is basically what I had written down. All right, so I showed you the no such element exception. So if you try to read past the end of a file, so in the previous example, if I would have tried to read 6 integers and I only had 5 written, you can catch the exception like normal. That's one of the possibilities. So you could throw in an extra catch and have a no such element exception in there. Or, and this is the better way to do it, and this is what I recommend, Scanner has a few extra methods. Scanner has a few extra methods. It has these has versions. So it's still next int, next double, next line, next. But it's a has next, has double, has next int, has next line. You can think of it like this. If you use one of these, you can think of Java as looking ahead a little bit. Look at what the next int is, or the next double, or the next line, and just check and see if there is a next int, or a next double, or a next line. Think of it as sort of asking that question. Is there a next int? The answer is either yes or no. So this is a Boolean. This returns true or false. So if there is a next int, so has next int, would be true. And then you would want to read it in. So let me show you how you might use something like that in our example here. So we know that this gives, let's see, let me go back to integers here. Let me change this back to 10. Let's say we don't know how many integers we have in our file. Here I knew there was 5, but what if we didn't know? I'm going to change this loop to a while loop. For now, I'm just going to put true in here, and I'm going to show you that we do indeed get the no such element exception. So when I run this, it'll print these out, but then of course I go through all 5, and then I try to read in a 6th, and nothing happens here because I have an infinite loop here. So I would read this file and try to continue reading the file until it crashed. That's where something like a has next int comes in. So while fin, so fin dot has next int. So you can think of it like doing this with the while. It says, all right, I'm going into this loop. Is there an int to read in my file? If there is, if it's true, then let's read it in and print it out. And then we reach the end of the loop and we go back to the top and we say, is there another int to read in? If there is, we do it, print it out, come back up. So it tests every single time. Is there another int to read in? So here I've read in 5. When it printed the 5, the 5th int out, it went back up and said, is there another int in this file? No, there is no more ints in that file. That's the end of the file. And so then we stop. So if you don't know how much data you need to read in, if you don't know exactly how much data you need to read in, using these has next calls is very important because it'll prevent you from even getting the exception that I showed you. And I can keep throwing numbers in here, and it doesn't matter. I can throw in as many as I want, and this will always work and print them all out. And it will never give me an exception based on it. Even if the file is empty. The file is empty and I say has next int, there is no next int, so it just skips it, and then we're done. So it'll read an empty file, and it'll read a file with as many ints, in this case, as I have. Any questions on the has next versions of these? All right, so keep these in mind. You can use them with any scanner, so it's not just for reading in files. You can use them otherwise, but they are most useful, I think, for files because you may not know ahead of time how much data there is to read. All right, so here's that example. It's basically that same thing. Here it's doing it with that test.txt that we had, but I just did it with the integer one that we had. So it's that has, in this case, it was has next line because we were reading in text. For the integers, it was has next int. So this one just slightly different because it's reading in text rather than numbers. So oftentimes this is how you will see files being read in with a while loop instead of with a for loop, for instance. All right, so that's pretty much it. I mean, that's how you read from files. So that there's not a whole lot to it. Just remember the structure of the try catch, and it's just using a scanner like we've been doing. But scanner can only read from a file. Scanner cannot write to a file. So we have a new class that we're going to use called printWriter. We do the exact same thing with a file. So we create a new file with whatever file name we want. But instead of a scanner, we use a printWriter. And you call it something like fout, for instance. Again, whatever name you want is fine, but something to denote that this is something to write to file is useful. Typically, we'll combine them into a single statement, just like this. So just like with the scanner, except it's literally just printWriter now instead of scanner. Creating a printWriter object, so this line right here, where we create a printWriter object and send in a file, it automatically creates the file if it doesn't exist. and it will remove all the existing data in the file if it does exist. So it will overwrite the previous file. It will not append to the file. It will overwrite it. And again, if the file doesn't exist, then it will create it itself. And it will show up in Eclipse under the project entry. Now, you may have to refresh the project view. And if I can remember where the setting is, I will go and show you a setting to have it automatically do that if we don't see the file pop up when we actually go and demonstrate this. So it's the same exact thing as Scanner. It's just a print writer instead. It also needs to be import, so I'll show you where that is too. All right, so when you create a print writer, you may also get a file not found exception. So you either need to catch it with the same try with resource that we just used for the scanner, or if it's in a method, you can add the throws keyword to the method. Now you might find that a little weird. How would the print writer that automatically creates the file if it doesn't exist, how might that throw a file not found exception? There's a few possibilities. For example, maybe you're trying to create a file in a location where, as a user, you don't have write permissions. Maybe you're not allowed to write to a specific folder or something. Then the print writer would try to create the file, wouldn't be able to do it, and throw the file not found exception because the file's not there. A probably less common scenario, but one that would probably be pretty bad for your computer is a completely full hard drive, for instance. If your hard drive was completely full, whatever hard drive you're using, whether it's an external one or an internal one, or you only have one hard drive and you completely filled it, then the print writer won't be able to make a file either. So there are situations, although less common than with reading a file, there are situations where trying to write a file might give you this exception. So Java still forces you to go through that same try catch that we just did with the scanner. The beautiful thing about print writer is that you've already done the exact same stuff that print writer needs. You've already done this before. You just use print, printf, and print line. That's it. So we're essentially replacing system.out with the name of our print writer, the fout, or whatever you want to name it. So you'd say fout.print, fout.printf, print line. And again, like I said, use the same modified try block. So you've already done this sort of stuff before. We're just changing it from system.out to our print writer object. And then you can do all the same stuff that you've already learned. So there's no extra things here except for this print writer piece that you have to do, which I find super useful because you don't have to learn some archaic way of using buffer writers and stuff to actually print stuff out. It's just easy print writer, and then use a bunch of your printfs, and scanner, use a bunch of your next methods that we've been using all semester. So hopefully this will be sort of relatively straightforward. So I'm going to go and outline this and sort of create something where we actually write a file. It'll look very similar to the one we did where we did the scanner, except we'll be using some print lines, printf, print. So I have a separate, let me close some of these here. So I have a separate, I've named it here outs. So it's just a separate blank file. We're going to start with our try catch. So I'm going to start with try. We're going to use try with resource because we have to open a file. So I'm going to put the parentheses there. If you're not using try with resource, if you're not opening a file for any reason, you don't have to put the parentheses here. You can leave them out. And then we have our catch. And we do still need the file not found exception. And we'll say x. And I'll put something in here real quick. File not found. Although, of course, I don't expect any issues here. My hard drive shouldn't be full. Then we'll do our print writer. So I'm going to say print writer. We'll call it fout equals new print writer. And then the same thing we did with scanner. New file, lowercase n. New file, and then whatever I want to name it. myfile.txt. Sure. Now, of course, let me put a file in here. So, of course, we do need to import all three of these: print writer, file, and file not found exception. All of them come from java.io. So that is something to remember when you're using these. And now I can just write whatever I want to. I can write whatever I need. So I can say something like fout.printf, and I can print out, I don't know, a couple of numbers, this, and a new line. So I print out, say, 5 and 10. Sure. And maybe I just want to print out a string after this. I can just say print ln for print line, and I can say hello. And whatever else I want. I can print anything else I want. Exactly the same way it would print to the console is how it's going to print into this file. If I run this code, it'll run. The code's completely done. So it ran, finished, done. But I don't see a file that pops up over here. It should pop up in the same place as these other files that I've created in the project directory itself. It's not going to show up in the source directory. It's going to show up in the project directory itself. Now, I can check that directory manually. So I can right-click on my project and say, show in System Explorer. So if I do that, let's see where that's going to pop up here, or if it's going to pop up. There we go. Here's that in class, and here is the my file. It's not showing up in my package explorer, so I'll go in and mess with the settings to show you that. But we do have my file, and here it is. Here's the 5, 10, and the hello. So it did work. It did create the file. It's not showing up in my Eclipse here. So if I can remember where the setting is for this, I'm going to show you. So if I say Window Preferences, we're going to go General, and yes, yep. Under General, and just clicking on Workspace, not doing the arrow down, but just clicking on Workspace. It's this setting, this top one right here. Refresh using native hooks or polling. So every once in a while, it'll refresh your package explorer. That's basically what this means. So if I check this, say apply, in a moment, it should refresh this. And there is my file.txt. So now I can see my 5, 10, and hello. Otherwise, it doesn't automatically refresh it for you. So I find that this one, it's going to use a little bit more sort of performance from your code or from your computer, because it's constantly going to be checking if there's been any changes sort of every so often. But I do find this quite useful. So again, that's in General, Workspace, and the top one here, refresh using native hooks or polling. So any new files you create will show up here. It might take a moment, but they will show up there. So that's how you write to a file. That's super easy. So you're doing some calculation, you need to write a save state for a game. Just do this. And then you're good to go. You can write out anything you want from any of the variables you have, write out any strings you want. Super easy. So hopefully this isn't sort of too complicated for writing files, because some languages, I tell you what, some languages make it really difficult or really much more complicated than it probably needs to be to write to file. And even Java has some older stuff that is a bit more difficult to write to file with bit streams and stuff like that. So print writer and scanner, because they work with files, they are quite useful because we've already used them in the past for reading from keyboard and writing to the screen. All right, so that's basically this sort of thing here. This prints out a couple more things, but you just use it the same way you use regular print when you do it. All right, so let's write a quick program that writes numbers from 1 to 100 in a file called numbers.txt. So yeah, so I'm just going to use this same one. And we want to write this to a file called numbers.txt. And let's throw a loop in here. I could do something. I could say fout.print yeah, whatever. I could print them as a string or something and say 1 like this. Like I could do that. That's going to be a real pain. So let's just print out these using a loop. So I want 1 to 100 to print out. And I'm going to use my integer I as the thing I print out. So my counter is what I'm going to print out. So I want 1 to 100. So I don't want to start this at 0. If I want to print out I, I'm not going to start at 0. Let's just start it at 1. And we want to go to less than or equal to 100 because I want to print 1 to 100. And then we'll say I++. And I can say f out dot. We could use print line. I'm just going to use printf. And I'm going to print out an int and a new line. And I'm print out I. So I run. Numbers.txt should get created. So it pops up over here because I had that setting set. And here is all of my numbers. We do get that extra line at the end. That may or may not be something that you want. So you could always have an extra check in here where if it's the last line, then you don't bother putting the new line. That's something that you might have to deal with. But this is essentially what we wanted. Numbers from 1 to 100 printed out in the file. So it's easy to do. You can throw in loops. You can print out as much stuff as you want. Again, things like save games and stuff, you probably have a lot of data. You know, the player's health, the player's position, the level they're on, you know, everything that you could possibly have with a player object, for example. Okay, so any questions so far about the print writer? Right. And then here's a possible solution for this. So this would basically just what I just written in there. All right. So there's a little bit more to talk about. A single program can read from one file and write to another file at the same time. So you can have a scanner that opens a file and a print writer that opens a different file. That's one of the keys here, a different file. In general, unless you're sort of careful and know what you're doing, never create a scanner and a print writer that points to the same file at the same time. It can be done, but we're not going to do it in this course. We're not going to do it in CS2. It's something that you do have to look into a little bit. The reason why is because when you're reading a file and when you're writing to a file, there are essentially file pointers that point to a different location that keeps track of where you are at in the file. That's why the scanner can read a line and then it knows what the next line is going to be because it's at a particular position in the file, just like if you put your cursor at a location in a file. You know where your cursor is. So it's the same sort of idea, but if you start writing to the file while you're reading it at the same time, then it's currently open. The buffer may not have written stuff out and you may be reading the wrong line. So there's stuff you have to do to sort of be careful when you're messing around with having a file open for reading and writing at the exact same time. So it's not something that you should really need to do that often anyway, but it can be done. It just takes a little bit of extra care to do. So keep that in mind. It's perfectly fine to open different files at the same time. You could open a file and then for reading and then open a different file for writing and then have a program that copies the contents of the file. That's perfectly reasonable. Just don't have them open to the same file at the same time. Let's do a quick reading and writing one. So we're going to do this in using that numbers.txt. So back here, we're going to use this numbers.txt one that essentially we just wrote. But we're going to be reading that numbers.txt, and we're going to be writing all of the odd values to a different file. So I do have a blank file for this, and I'm going to show you how you can open for reading and writing two different files at the same time. So again, I'm going to put my try in here. I'm just going to outline this all. Put my catch in here, and we're going to do file not found exception. And we'll do our standard stuff. File not found. and our system.exit. All right, we're going to open two files. One of them will be for reading. One of them will be for writing. So let's do the reading one first. We're going to read in from numbers.txt. So let's create a scanner. This will be my fin. This will be a new scanner, new file, numbers.txt. And I automatically put that include in there for me, or that import in there for me. And the other ones I need to add myself. So remember, I need file, file not found exception, and scanner, since I added all those pieces. Now it kind of looks like you can only open one thing at a time with this try with resource thing. But you can actually put more in. So I'm going to move this down slightly like this. As long as I put a semicolon here, I can put another thing inside of this parenthesis for my try. So I could say print writer, f out equals new print writer, new file, and I'm going to name this file odds.txt. I don't technically need another semicolon after this. And you want to make sure to import the print writer. I don't technically need a semicolon after this, but I do need a semicolon between these two. So opening more than one file is perfectly fine inside of this try catch as well. And they will both automatically be closed as soon as the try finishes. So you can open up as many files as you want. I could open up a whole bunch of files for reading, a whole bunch of files for writing. I just had to put them all in here separated by semicolons. So again, this parenthesis, the one that is, I have auto formatting on save on, so that's why it moves this stuff around. The one that is right here contains both of these. Of course, when I save, it pushes stuff back. All right, so inside of my try is right here. So let's read in those numbers and write out only the odd ones. So for our reading, we want to do, let's see, we want to say something like while. I'm going to use the has next int. So while fin dot has next int, that's has next int, go. So while there is another number to read in, let's read it. So I'm going to say int value equals fin dot next int. Okay, so we just got the value. If this is where we're going to figure out if it's odd. If my value mod 2, so if it's divisible by 2, so in other words, if the remainder is 0, that would mean it's even. So if it's divisible by 2 with no remainder, then it's an even number. So how do I say if it's an odd number? Well, if it's not divisible by 2. So if the value has a remainder after I do a mod 2, then I'm going to write it out. So I'm going to say f out dot printf %d %n, and I'm going to print out value. So it might look a little complicated. I got up some f-ins and f-outs and all that sort of thing, but really it's just saying if there's another int in my file, read that int in. If the value is not divisible by 2, in other words, so if I take the mod 2, if there is a remainder, so if the remainder is not 0, then print it out to my odds.txt. So if I run this, odds.txt should show up here momentarily. There it is. And if I open it, there's all my odds. So that's how I can read a file and then output to a different file, all in the same try catch block. And if for some reason one of these wasn't available, so if numbers.txt didn't exist, or I could not write odds.txt for some reason, then I would have gotten the exception. In this case, it's probably useful to have that, to do that string printing thing, to say ex.getMessage, because then you would know what file had the problem. Because file not found, I don't know which one it corresponds to. Is it fin or is it f out? So using the get message here would be useful, because then it would tell me which file had the problem. But in the end, reading and writing to files is actually pretty simple in Java, which is, like I said before, which is definitely nice. It's just using your nexts and using your prints like we've been doing all semester, with a little bit of extra stuff in there, like using the has next for some, has some uses for file reading and writing. All right. Any questions on this so far? All right, and then I talk about this that sort of stuff I mentioned, multiple files with the try. I sort of talk about that in the slide here. So basically, just like what we just did in the file, you have one semicolon, you put the other one. You don't have to have a semicolon. So in the code you just saw, I didn't have a semicolon here, but you can put one in. So it doesn't matter. It doesn't hurt to add it if you want to be sort of more explicit that that's the end. But just reading in two files within the same try with resource. All right, we've used strings so far for the file name, but it doesn't have to be hard-coded. You can put whatever string in there you want. So you could ask the user for a file name. So if we go all the way back to this beginning one here, this one where we were sort of reading some lines. Let's get rid of a little bit here where we just read the first line and print it out. Maybe I want to ask the user what file. So I could say something like system out printf, something like enter file name. Now this would be reading from the keyboard. So I need another scanner. But this scanner is not to a file. This is my regular scanner that we've been using all semester, the one that reads from the keyboard. So I can say input scanner input equals new scanner. And this points to a different place. The one down here points to a file. This one points to system.in. So I can say string name equals input dot, we'll use next. And then instead of having a string here that's hard coded, I can say name. So if I run this, as enter file name, test.txt. And there's the first line from test.txt. Hello. So it doesn't have to be a specific hard coded thing that you put in there. It can be whatever string you want. So maybe I want numbers.txt. Spelled it wrong. Try it again. Numbers.txt, and there's the 1. That's the first line in my numbers file. So if you want to allow the user to type something in, this is the way to do it. Just use another scanner pointed to a different place. Typically, you don't want multiple scanners pointed to the same thing, to the same file or to system.in. That will cause problems. But having multiple scanners that all point to different things, perfectly reasonable, perfectly fine thing to do. So that's an easy way to read in something for a file name that the user gets to type in. So this is a very common sort of action to use in programs. And I have an example of that. This one's printing something else out for enter the output file name, and it's printing out the cube of numbers from 1 to 1,000. So similar thing to what we just did, just in this case, writing a file based on a file name that you give the user. So same sort of style thing. All right, so we got essentially one more thing to mention. You can pass a scanner to a method as an argument. This is in principle what you should do if you have any input that's happening in the method. The same is true for a print writer. You either need to catch the exception, the file not found exception, within the method that you're sending it to, or using the throws keyword. So let me show you what something like that might look like. So let's say we want to take this, let's go to this one here. Let's say we want to take this one, and I would rather have the code in my try I'd rather have that code in a method itself. So maybe I'll have a method here called public static void write numbers. And I want this code in there so that I can just call write numbers like this. So it's fine for me to leave this outside. I can use the try catch here. I do need to send in fin. I need to send in my scanner so that I can use fin down here. So I would say scanner, let's just call it S here. And there we go. That way, this scanner here actually is I could use this either in the console or in a file. I can actually send in whatever scanner I want. It's a little more flexibility. So as long as you're catching when you create the scanner, as long as you're still catching the file not found exception, then you're still good to go. So here it read in that file and printed them out. So you can still send in the print writer or the scanner as method arguments and use it in exactly the same way as you normally would. So there's nothing sort of special going on here. Oftentimes people will do this. You might have a few things you need to do. So you might have like a write numbers, and then you might have a compute. You might have like a compute method or something, and then you might have a file writer where you want to output to file or something. And so you'd send in like an F out, for instance. So you might have a few separate things you're doing, and rather than have a whole bunch of code inside of the try, you just call a few methods like this. And then this will catch any of the file not found exceptions that you might have to deal with. So in the code on the slides here, I have a sort of a similar thing like that. Here we got print writer, output numbers, and it does some calculations or whatever, and then it has the try catch around it. So feel free to send these as methods or as method parameters as well. Feel free to send them to other methods to do stuff. There's nothing stopping you from doing that. Okay, so summary-wise, this is relatively easy to use, and that's one reason why I like Java File I/O. You can read and write files just like using system.in with a scanner, and just like using system.out for using print and printf and printline. The file object itself, when you say new file and then give a name, that actually represents the file in your program, like the actual file on the drive. Scanner then interacts with that so that you can use all of those next methods or those has next methods, has next checking for more values that may exist within the file. The print writer takes the file and allows you to use all your print methods that we've been using. Use the try with resource, that thing that we've been using the whole time, so that you automatically close the scanner or the print writer when the try with resource is done. It's the easiest thing to do, so you don't have to remember to close out the files. As soon as the try with resource is finished, then you're good to go. So file I/O overall isn't too complicated. It's just a little bit of extra syntax to remember when you're reading or writing files. All right, so next time. The exam is next week. The exam is next Thursday. We will do a review on Tuesday. So that's something to be around for. The exam will be the same style that was last time. So it'll be on Blackboard, all that good stuff. There is a lab tomorrow. It'll be a little bit more complicated than some of the previous labs. So you'll want to be ready for that as well. We'll do the normal thing. I'll talk about the lab ahead of time, give you some hints on it, and then you guys can work on it together in the breakout rooms, and myself and Dan will jump around and help folks out as you need it. So that is the plan. So next week is mostly just focus on test stuff. So that's coming up. After that, we'll have a few more lectures. There's actually not a whole lot left. I think there's only after the exam, there's only 6 lectures left, and 2 of those will be, I think there's 6, maybe there's only 5. 2 of those will be getting ready for the final. So we don't have a lot more stuff left to cover, but I do have a plan for a little bit more OOP stuff. We'll do a project over the course of a week where we sort of build a small sort of console type game in the in using OOP to give a little bit more practice for all those components. So otherwise, that is it. So I will see you guys tomorrow.